In this section, we will create a simple model without any details, and then we will apply finite element analysis to make sure that we selected the right sections. If it's okay, after that we will go to the fully detailed design. In the future, you may need to modify some dimensions, like the height or the width or the angle, for example. That's why we need to define some global variables, and then we can change them easily when we need to modify the design. To define some variables, you need to have equations here. If you don't have it, just right-click anywhere here, and then select Hide Show Tree Items. Here, you will find equations. Make sure to have it Show, then hit OK. Now, for the system of units, I will use mmgs, millimeter gram second. If you have equations here, just right-click and select Manage Equations. I will set some global variables here, so just click here and let's start with the height. Once you write height, then click in this field, and let's say I want the height to be 4,845 millimeters, and you can go down and select millimeter from here, and you have this symbol, then click here again, and you will have another field. Another value I want to define is the length, so I'll write length, and here I want this to be 6,000 millimeters. You can simply hit enter and it will be defined. If you don't have the millimeter listed here, so once again click here and another click, you will have units, go down to millimeter, and now it's listed. Let's define an angle. Click here, and I want this to be 5 degrees, so go down to units and select degrees. Finally, I want to define a column-to-column distance, so I will call this C to C distance, and I want this to be 5,000 millimeters. Click here. Once you have these defined, hit OK. And now, if you open this menu, you will find the height, the length, the angle, and column-to-column distance. Whenever you need to make some modifications to your model, you can simply click here and just modify these. Before we start creating the model, it's very important to start the first sketch on a proper plane. You can start in any plane you want, but some planes are better than the others. So now we will draw the side view of this structure. So if you start on the top, then you will need to reorient the model all the time. And then when we go to the finite element analysis, we will need to redefine the direction of gravity, and so on. So from the beginning, start with a proper plane. In our case, the right plane will be perfect. So start a sketch there, and we need to create the column. Then make sure it's vertical, then select Smart Dimension, and here hit the equal button in your keyboard, and from the global variables select height, and hit OK. And as you can see, we have the equation symbol here, which means this number was listed by an equation or a global variable. Then select midpoint line and snap to this line and draw a line like this. Hit the escape button on the keyboard to exit the command and select Smart Dimension again and select this line. Now make sure not to go this way, because in this case you will have the horizontal projection, and here we need to define the true length of this line. That's why you need to go a little bit closer to the line, and here hit the equal button and set this to the length, and hit OK. Then finish the Smart Dimension, and this time start with a center line, snap to the origin, draw a horizontal line, finish the command, and then select this point, hold Ctrl with this point and make vertical. Finally, we need to define the angle, so select Smart Dimension, select this line and this one, and here hit the equal and set the angle, then hit OK. Here I need to place 4-inch pipe on this line. That's why we need to have some offset between this pipe and this point. So select this point and snap to the midpoint here. Then let's set this to 120 for now. We can modify it later if it's not okay. Then select another line and start somewhere here and snap to this line. Now set a distance between these 2 points and make sure to have the true length, not the horizontal projection, and set this to 400 millimeters. And select this point and this point, and let's set this to 800 millimeters. Once done, drag this here and drag this and draw another line, snap to this point and snap to this line. And now select Smart Dimension, once again between these 2 points, make it true length, and here hit the equal, and this time select this 400. What will happen now is that whenever you modify this dimension, this one will be modified too. Let's see this. If I double click this one and set it to 500, then this one is 500 too. Now we are done with creating this side, so finish this sketch. And let's go to Weldments, then Structural Member. Here, let's go to the ISO. For the type, we need to place a circular tube. And for the column, we want it to be around 10 inches. So that's why you need to go to, let's say, 273, and I want the thickness to be 8 millimeters. Once done, select this line, and here we have the column. Hit OK, and once again select Structural Member, and from the ISO we need to place this pipe, and it will be 4 inches pipe, and that's why from the type keep it circular, and for the size let's go to 114. We need 114.3, but we need it to be 8 millimeters thickness. So select this line and hit OK. And once again, select Structural Member, keep the same options, but for the size, we need this to be 2.5 inches. That's why we need this to be around, let's say 76, and we need the thickness to be 5 millimeters. And then select this line and select this one, then hit OK. Before we proceed, we need to create some trims, like here. So select Trim Extend. Now, bodies to be trimmed, I want to trim this pipe. And the trimming body, I want this body to trim this pipe. So once you select this one here, whatever we have inside will be trimmed. For sure, we need to keep this and to keep this. If you change this to discard, it will be removed. So make sure to have these and then hit OK. We need to do the same, but this time with these 2 pipes. So select Trim Extend, select this one, then for the trimming boundary or the trimming body, we want this one to be the trimming body, then hit OK. And now we have this pipe empty from inside. Now we need to create another side of this, so select Linear Pattern, and for the pattern direction we need to select a plane that will be normal to the direction of pattern. In this case it will be the right plane. So for direction 1, when you select right plane, here you will have this plane selected, and as you can see we have a preview for the pattern direction, which is correct, and for the number of instances, we need 2 instances, and for the bodies, and as you can see here, I selected bodies because I want to have multi-body part I need to be able to treat each body separately. So for the bodies, make sure to select from the right to the left and to select the whole thing. Now, let's go up. For the spacing, select everything and then hit the equal button. And from here, from the global variables, select C to C, which is the column to column distance. Then hit OK. So here we placed the two columns of this structure. Next, we need to place the purlin. It will be a customized cross-section, and that's why we will create the cross-section and then we will place it. Hello again. Now we need to place the purlin. The problem with the purlin is that it's a customized section. We don't have it in the library. That's why we need to define the section, then we need to place it. To define the section, we need to start a new part. And here, before you start, make sure to select MMGS for the system of units. And let's start with a sketch on the front. Select midpoint line, start in the origin, snap to the origin. And then draw a vertical line. Then proceed with a horizontal, then another vertical. Now let's set this to 160 and this one to 70 and this one to 40. Select line again and draw two lines here, one horizontal and one vertical, and this time select this line, hold Ctrl and select this one, then set them to be equal. Then select this one, hold Ctrl with this one and make equal. And once done, and when you have a fully defined sketch, let's apply some fillets. Select fillet, and we need this to be 8 mm, the radius. Then select this corner, and don't worry about this message, just keep selecting the four corners. Hit OK. And now we have the fillets placed. It's the time to offset these lines. So select offset entities. And we need this section to be 3 mm thickness. So set this to 3 mm and make sure to select chain, then select any of these lines. We need this to be inside. If you have it outside, you just need to click reverse. Then I need these ends to be closed. That's why I will select cap ends and I need it to be closed with lines, not arcs. Once done, hit OK. Now finish the sketch and we need to save this to our library. This is the most confusing part of the process. Before you save this, you need to know where to save it. In order to know where you save SolidWorks Weldment profiles, you need to go to Options, and then you will find File Locations, and for Show Folders for, you need to go all the way down until you find Weldment Profiles. In my case, I have two destinations. I have the C, Program Files, SolidWorks Curb, then SolidWorks Lang English Weldments Profile. I have another folder, which is the C, SolidWorks Profile, then I have all the standards. If you want to do it the easy way, you need to keep in mind this destination. After that, you need to save this file. So you need to select the sketch from here, then to select Save As, and it's very important to select the type. So the type will be Library Feature Part. This is very important. And then you need to navigate to your destination folder. In my case, it will be on my C drive. I have SolidWorks Profiles. And inside of here, I have all these standards. Now, I want you to pay attention to a very important point. Let's go inside the DIN, for example. If you save your part here, then you won't be able to place it in the 3D because you will still have subfolder. So when you go in, here you have the type. then you need to go inside any of these folders, then you need to save the new section. That's why you need to pay attention to the subfolders. In my case, I will go to SolidWorks Profiles, and I have a folder that I called Customized, and inside of it I have a subfolder which is Customized, and then I have Flat Bars, and then I can place it here. I will give it a name of Purlin, then 160 multiplied by 3. Then hit save. And now we have this small symbol here, which means this is a library feature part. If that's okay, go to Window and go back to the part you created. Now the purlins will be placed here. That's why we need to create a plane so we can draw our sketch, then place the purlin. If you select Reference Geometry, then a plane, you can set a plane that is tangent to this pipe and tangent to this pipe. That's why select this pipe, and this will be automatically detected tangent. Then select this pipe, and here we have another tangent, and the plane is created. Hit OK, and let's start a sketch on the new plane. Now I will hide this plane and select Align, and let's start somewhere here and let's end it somewhere here. Now pick a center line, snap to the midpoint, and then connect this line with this one. Finish the command, select this line, then make vertical. And here it's already coincident with this line, so we need to set an offset value, and this should be, let's say, 100 millimeters. Then finish the sketch, and I'll go to Weldments, Structural Member. This time I will go to Customized, for the type Flat Bars, and here I have the name of Purlin 160 by 3. Then select this line, and here we have the purlin placed. Go all the way down and select Locate Profile, and here I need to select this corner. Now this line is tangent to this pipe, which is correct, then hit OK. Now we need to pattern this purlin. To do so, we need to set a reference here. Now I have 100 millimeters offset between this face and the purlin, and I need the same offset to be on the other side here. That's why let's go back to this sketch and edit it. Then pick a point and place it over this line. Then select Smart Dimension and set a dimension between this point and this edge, and hit Equal. Then zoom out and select this 100. Now, whenever you modify this 100, this one will be modified too, and this way you will keep the symmetry of this pattern. Now finish the sketch and go to Features and select Linear Pattern. For the direction of the pattern, zoom in and select this line. Now we need to pattern this up to a reference. So the reference in this case will be this point we created here. Now go down, and for the bodies, let's select this purlin. And now instead of a spacing, we need to define a number of instances. It should be 6. And finally, you have this option, which is centroid, and we have selected reference. We will go with selected reference. So now for selected reference, you need to go to the original Purlin and select this face. What will happen now is that SolidWorks will take this Purlin up to this point, and the reference of the Purlin will be this face, which means this face will meet this point here. And that's how you can keep the 100mm offset we have here. Let's have an overview. So now we don't have any interference with this pipe, then it's okay. The number of instances is 6, and we kept the 100 offset here, and we kept another 100 offset here, then hit OK. So that's it for creating the simplified model. In the next video, we will run the finite element analysis, and we will see if we have selected the right sections. Thanks for watching, and see you in the next video. Hello again. Now we will run finite element analysis to make sure that we chose the right sections. Before doing so, we need to define a material. So go to Material, right-click, then Edit Material. Usually this type of a structure will be made of ASTM A36 steel. Hit Apply, then Close. Now you can measure the mass of this structure. I will select meter kilogram second, and then go to Evaluate, and then Mass Properties. And here, the mass of this structure is 1088.68 kilograms. To access the Finite Element Analysis tab, we need to right-click any of these tabs, then select SolidWorks Add-ins, and then you will find SolidWorks Simulation. Now you will see that we have Simulation tab. Access this tab, then select New Study, and here we have the types of simulations that SolidWorks can perform. In our case, we are only interested in static. Select Static, give it a name, and then hit OK. Before we start talking about the analysis, we should pay attention to these balls here. We have two colors, as you can see. This one means that this is a free end, and this one means that we have a connection here. So as you can see here, we have a connection between this pipe and this one. So we have this ball in this color, and here we have a free end, so we have it in this color. And that's why now we can say we have a problem with the Purlin, because SolidWorks doesn't recognize that they are connected to this pipe here and here. So before we start our analysis, we should solve this problem. You need to tell SolidWorks that you have a connection here and it's not a free end. If you run the analysis this way, then this Purlin will just fall down. Nothing will hold it, and you will have a crazy amount of displacement. There are many solutions to solve this. The first one is that we may try to extend this a little bit here and a little bit here, so SolidWorks can recognize that we have an intersection between these structural elements. To do so, let's go to the model again, and here we need to select this sketch, then Edit Sketch, then go Normal to, and here, instead of having this coincident, select this relation, then hit the Delete button on the keyboard. Now this point is free to move, so drag it somewhere here. Once done, go to the other side, and now we need to free this point, so select the relation, then hit Delete, and now move this point and snap to the edge here. Once done, finish the sketch, and now let's go back to the analysis and see the difference. So if you go to Structure 1, then the joints will be recalculated, and here the color is different, which means SolidWorks recognizes that we have a connection here, and so on. So it's very important when modeling structural members to make sure that the connections are correct. Now we need to define a fixture. So obviously this structure will be fixed here and here. That's why let's go to Fixtures, then Fix Geometry, and here select this ball and this one. Fixed geometry means this joint here has 0 degree of freedom, which means it cannot translate in the X, Y, or Z, and it cannot rotate about any of them. It's totally fixed. Once you selected them and they are listed here, then hit OK. Now let's talk about loading this structure. First of all, we need to make sure that this structure can hold its own weight. That's why we need to define a gravity load. So right-click here and select Gravity. Before you hit OK, you need to make sure that the direction is correct. So since we have the top plane here on the floor, then the direction of the gravity will be perpendicular to this plane. And that's why it was very important to start our first sketch on this plane here, not on the top. Because if you start on the top, then this shape will be this way, and here you will need to define another direction for the gravity. So it's very important to pick the most proper plane to start with. Here, as you can see, we have the acceleration of a gravity value. If you have the vector in this direction, then hit OK. After that, I want every squared meter of the structure to hold 150 kilograms. So we have 6 meters in this direction, and we have 5 meters in this direction. So the total is 30 squared meters. Then I want 150 kilograms per squared meter, so it will be 150 multiplied by 30. So the total load will be 4,500 kilogram force. Now right-click here again and select Distributed Mass. Then you need to select the elements. You can select many different things here, like vertices or points. You can select joints, and you can select beams. In our case, beams will be the best solution. So select beams, then select this one, and all of them. And finally, the total mass, I want it to be 4,500 kilograms. And make sure you have the right unit here. If not, you can change between these, and you can have different units. I have 4,500 kilograms, then hit OK. Now, when you define a mass, it will follow the direction of the acceleration of a gravity, which means this load and the gravity goes in the same direction. We already defined the material from the beginning, and after defining the fixture and defining the load, we are ready to create the mesh. So right-click here and select Create Mesh. If your mesh is correct, now we are ready to run the analysis. So select Run this study. Here you have the results. The first thing is the stress. The maximum stress here is 8.8 multiplied by 10 to the power 7. And as you can see, the unit is Newton per square meter. The yield strength is 2.5 multiplied by 10 to the power of 8. And here it's 8.8 to the power of 7. Which means this structure is safe, and we are still way below the yield point. But another important aspect to consider is the displacement. And that's why, double-click here. And here we have the displacement in millimeters. So we have 9.8 multiplied by 10 to the power of 1, which means we have 98 millimeters of displacement, which is relatively high. So the structure is safe, but the displacement is high, so we need to find a solution. As you can see, the maximum displacement occurs here, right in the middle. So what if we have something that connects all of these members? It will help with the displacement. To solve this problem, we have many solutions. But always we should go with the easiest one. You should keep in mind the price and the fabrication. So let's go back to model, and here, go to features, reference geometry, plane, select this face, rotate the view, and select the lower one, and here you will have a plane in the middle. Hit OK, and start a sketch there, then start with a line, snap to the midpoint here, then go a little bit up, then draw this line, something like this. Don't worry about the dimensions for now. We only need to verify the analysis. Once done, go to Weldments, Structural Member. Let's go to the GB. Let's pick a round bar, and let's pick, let's say, 35 millimeters diameter. Then select this line, then hit OK. Now we have this round bar that will connect all of these members. It will help with the displacement. Let's double check this. Go back to Structure 1, and here, before you run the analysis, make sure that the connection is correct. And here we can see that SolidWorks recognizes that we have a connection here, and here, and here. So it's okay. Don't worry about this because it's really a free end, which is correct. And the same way here, this is a free end, and that's why the color is different. If that's okay, we have this symbol here, which means we need to remesh this structure. So from here, select Create Mesh. If everything is fine, then select Run this study. Now, as you can see, we have a higher value of the stress, and you can't tell where is this value. If you select this, then select Annotation, and you can see that we have a higher value of stress here. Adding this member will cause some stresses to be transmitted in the structure, but we are still way below the yield point. Let's see the displacement value. And now the maximum displacement we have is 42 millimeters, which is still a little bit high. So we need to solve this again. So we need to find another solution, or we can keep this and think of another solution. A good solution could be increasing the thickness of this purlin. To do so, you need to go to the Weldment Profiles library and then to modify that sketch. So I'll navigate to that. And here I have it. I will edit this sketch, and instead of having 3 millimeter thickness, now I'll place this to 4 millimeter. Then hit OK, and hit Save, and then exit this. And now it's not automatically updated. You can double check this by going to Evaluate, then select Measure, and this time select this edge. Now you can see we have 0 meter because the unit of meter is relatively high. So open this and select millimeter gram second. Once again, go to Measure and select this edge. Now it's still 3 millimeters. So how can we update this? To update it, simply go to Flat Bars, Purlin, and then Edit Feature. Select any other profile you have. And after that, go back to the one we want, which is this one. Then hit OK. And from here, select Rebuild and Measure, and let's see it now. So now it's 4 millimeter, which means we are ready to run the analysis again. So go to Structure 1. And as you can see, we need to remesh this structure. So select Create Mesh. Everything is fine. Then select Run this study. Now we are okay with the stress value. Let's go to the displacement, and here we have 2.8 multiplied by 10, which is 28 millimeters. Here I want to point to a very important point. Sometimes you lose the fixture. As you can see here, we have a problem. This point is fixed, but this one is not. And if you go back to fixed and edit the definition, you will only find one joint. That's why you need to select this. And now we are sure that we have these two columns fixed. Hit OK. Then select Create Mesh. Then run the study. Now the maximum value of the stress is way below the yield point, and for the displacement we have 19 millimeters of displacement, which is acceptable in our case. We can reduce the size of this column, but in some cases it's not only about the analysis, it's about the shape. So for this structure, the shape of this column and the size of it is okay, so we will keep it. Right-click Results and select Define Factor of Safety Plot. We need to plot the factor of safety of all the bodies, so we'll keep this to all, and here keep this to automatic, and advanced, and under advanced options you have set upper limit for factor of safety. I don't want to see a factor of safety of 100, let's say, or something like this, so I will select this option and I need to see 4 as the higher value of the factor of safety. Then hit OK. And now here we have the maximum, which is 4. In reality, it's way more than 4, but I'm not interested in seeing this number. I'm only interested in the minimum factor of safety, which is this one, 3.1. And the weakest point in this structure is this one. You can click here, then Annotation, and it will connect this value to the location, which is here. Let's say we need to have a more accurate results. In this case, let's go back to the load here, edit the definition, and instead of distributing the load only on these beams, click here and let's add this bar. Then hit OK. Select Create Mesh. Then select Run this study. Now, as you can see, the stress were distributed in a different way, which is more accurate now. And if you go to the displacement, we have 1.8, which is around 18.2 millimeters of deflection. And for the factor of safety, the maximum factor of safety now is 2.8, which means the more details you add to the structure, the more accurate results you have. For now, if you want this to be perfect, you will need to add a plate here, and then you need to apply the load over this plate. But in our case, we are way beyond the yield point, which means that this is safe, and these analyses are enough to make sure that this structure is safe. The last point I want to point to here is that this shape you see is not real. This is just a representation of the stress, because we have deformed result. This shape will be the same. You won't notice any deflection, but this representation helps you to imagine the locations of the stress, and it helps you to imagine the locations of the displacement. So now, when I have this here, I know that the maximum displacement will be here, and it will be the same here. Let's go back to model, and now we are sure that the sections we selected are correct and can be used to design this structure. That was the first stage in the design process. Now we will start to design the real model that will be fabricated. Thanks for watching, and see you in the next video. Before we proceed with the actual modeling, we need to talk about the concrete base. Here is the real model. as you can see, we have this concrete base. In order to be able to design this concrete base, you need to have the reaction forces on this base. Once you have them, then you can design this base. So now we need to get these values. So if we go back to the analysis, we can go to results, then list result force, and here, as you can see, we can select joints. So I'll select this joint and this one, then click update. And here, you will have all the data you want. You will have the force on the x-axis, and you will have the force on the y-axis, which is the most important one here, because it's a compression force and it's the biggest one. Then you will have the moments. They are not big, but in some structures, when you have a closed structure, for example, the wind load will cause some moment here. Imagine if this structure is closed here, and if the wind comes from here, then it will try to push this structure, and in this case, you will have some moment here and here. For now, you need to take these reactions with these directions and to give them to the civil engineer so he can design the concrete base. Hit OK, and now let's go back to Model, to Features,